Bismillahirrahmanirrahim. Assalamu alaikum everyone. My topic for today is probability introduction, the addition rule and the multiplication rule. And the way to get started is to basically quit talking and begin doing. My name is Dr. Rida Shahram Sarver, and under supervision of Dr. Professor Sarah Afzal, I will begin today. My learning outlines for today are the definitions of probability, the basics, examples, formula, types of probability, applications of probability, addition and multiplication rule, recent advances, as well as MCQs. Learning outline. At the end of this presentation, participants will be aware of the basic terminologies of probability, their meanings, and have a grasp on the rules of addition and multiplication with examples. Basically, what is probability? Probability is simply how likely something is basically going to happen. Whenever we're unsure about the outcome of an event, we can talk about the probabilities of certain outcomes and how likely they are. The analysis of events governed by probability is called statistics. Probability is a way of expressing knowledge of belief that an event will occur on chance. Probability basically originated from the Latin word which means approval, and it is a branch of math that studies patterns of chance. The idea of probability is based on observation, and probability basically describes what happens over many trials. The best way of explaining probability is basically by flipping a coin. As you guys know, there's two possible outcomes, either heads or tails. And what's the probability of a coin landing on heads? You might intuitively know the likelihood is half-half, which is basically 50%. But how do we work that out? Probability is the number of possibilities that meet by conditions over the equally likely possibilities. Simply explained, it basically is the number of ways something can happen over the total number of outcomes. And in that case, because basically getting heads is one out of the two probabilities, the answer is going to be 50%. The formula for probability is defined as the possibility of an event that is going to happen, which is equal to the ratio of the number of favorable outcomes and the total number of outcomes. And it's basically expressed one on top of the other. Examples of probability is basically, for example, there's 6 pillows in a bed. 3 are red, 2 are yellow, and 1 is blue. What is the probability of picking a yellow pillow? The probability is basically equal to the yellow pillows in the bed divided by the total number of pillows, which is 2/6 or 1/3. Probability tree. This tree basically helps to organize and visualize the different possible outcomes. Branches and ends of the tree are the two main positions. Probability of each branch is written on the branch, whereas the ends are containing the final outcome. Tree diagrams are basically used to help figure out when to multiply and when to add. And below, you guys can see that this is a tree diagram for a coin, in which basically you can see the branches and the probability, which is 0.5, 0.5, and the outcomes, which are head and tail. There are three major types of probabilities, which are the theoretical, experimental, and axiomatic probability. The theoretical probability is based on the possible chances of something that is going to happen. The theoretical probability is mainly based on the reasoning behind probability. For example, if a coin is tossed, the theoretical probability of getting heads will be half. An experimental probability is based on the basis of observations of an experiment and can be calculated based on the number of possible outcomes by the total number of trials. For example, if a coin is tossed 10 times and a head is recorded 6 times, then the probability for heads is 6/10 or 3/5, and it's going to be simplified. Axiomatic probability are a set of rules or axioms that are set which applies to all types. These axioms are set by Kolmogorov and are known as Kolmogorov's three axioms. With the axiomatic approach to probability, the chances of occurrence or non-occurrence of events can be quantified. And basically the axiomatic conditional probability, on the other hand, is the likelihood of an event or outcome occurring based on the occurrence of a previous event or outcome. Basically, how do we calculate the probability of an event? We assume an event, which is E, can occur in R possible ways out of a sum of it, N probable or possibly equal likely ways. Then the probability of happening of the events or its success is expressed as P equals to R/N. The probability that the event will not occur, or known as its failure, is expressed as N minus R/N, which can also be written as 1 minus R/N. E dash represents the event that will not occur, and therefore we can express it as the following formula. This means that the total of all probabilities in any random test or experiment is equal to 1. What are in order to understand this better, we need to know what are equal likely events, and this is basically when the events have the same theoretical probability of happening, that they are called equal likely events. The results of the sample are called equal likely if all of them have the same probability of occurring. For example, if you throw a dice, then the probability of getting 1 is 1 over 6. Similarly, the probability of getting all numbers from 2, 3, 4, 5, and 6 is 1 over 6. Hence, the following are some examples of equal likely events when throwing a dice, which is basically getting 3 and 5 on a dice, getting an even number or an odd number on a dice, or getting 1 or 3. And these are all equal likely events since the probabilities of each event is basically going to be equal. Then what are complementary events? The possibility that there will be only two outcomes which states that an event will occur or not. Like a person will come or not come to your house, getting a job or not getting a job, are examples of complementary events. Basically, the complement of an event occurring in the exact opposite that the probability of it is not occurring. Other examples include whether or not it will rain, the student will pass an exam or not, or whether or not you will win the lottery or not. Applications of probability. Basically, probability has a wide variety of applications in everyday life. Some of the common applications which we see in our day-to-day life basically include checking the results of different events. Like, for example, choosing a card from a deck of cards, flipping a coin, throwing a dice in the air, pulling a red ball out of a bucket of red and white balls, winning a lucky draw. Other major examples of probability include that it is used for risk assessment and modeling in various industries, weather forecasting or prediction of weather changes, probability of a team winning in a sport based on player strength and the strength of the team, and in a share market, the chances of the hike of share prices. Now, the addition rule of probability. The addition rule of probability states that the probability of two events is the sum of probabilities of two events that will happen minus the probability of both events that will happen. And mathematically, it is expressed as follows, which is basically the probability of A and B's union, which is going to be equal to the probability of A with the added to the probability of B minus the intersect of the probability of A and B. So basically, written down and simplified, this is what it means. And when do we apply the addition rule? When we need to find out any outcome in A, any outcome in B, or any outcome in both A and B. An example of the addition rule, there's basically two. The first example is the simpler one. And when there are two events that are basically A and B, and they're mutually exclusive, that means that they are not going to be dependent on one another. The probability that A or B will occur is a sum of the probability of each event, which is simply A's probability and B's probability added together. And an example of this can be seen when a single six-sided dice is rolled. And what is the probability of getting either a 2 or a 5? Since we studied earlier that it's basically 1 out of 6. So you can add these together. That is the probabilities of either getting 2 or 5, which is going to be 1 over 6 plus 1 over 6, which is going to be equal to 2 over 6, or simplified 1 over 3. Addition rule number 2. This is the one that I've written earlier. And with this basically means that when two events A and B are non-mutually exclusive, the probability that A or B will occur is basically going to be expressed as the sum of the probabilities of A and B minus the probabilities of A and B. In the rule above, this basically refers to when there's an overlap of two events. And now I'm going to demonstrate this to you guys with the help of an example. Basically, in a math class, there are 30 students, 17 are boys and 13 are girls. On a unit test, 4 boys and 5 girls basically got an A grade. If a student is chosen at random for this class, what is the probability of choosing a girl or an A student? So this is basically, the formula has been expressed in the form of the girl and getting an A grade. So first, you're basically going to add the probability of getting a girl, which you guys know there are 13 girls over 30, added to the probability of the kids who scored A grade, which were basically 9 over 30, minus the girls who scored an A grade, which was 5 over 30, and simplified, it's going to be 17 over 30. Another example of the addition rule is basically when an ice cream cup has 3 scoops of chocolate, 4 scoops of vanilla, and 3 scoops of butterscotch ice cream. What is the probability that if you randomly sample the ice cream, you will either taste chocolate or vanilla? So basically, there's 3 scoops of chocolate. So the total possible outcomes of this are basically going to be 3 plus 4 plus 3, which are the total number of scoops. So 3 over 10 plus 4 over 10 minus 0, which is going to be 7 over 10. So in short, to find the probability of an event A or B, we must first determine whether the events are mutually exclusive or non-mutually exclusive events, and then we can basically apply the addition rule. The addition rule number 1 states that when 2 events are mutually exclusive, the probability that A or B will occur is the sum of probability of each event, which is simply the probabilities of A and B added. And the addition rule number 2 is that when 2 events A and B are non-mutually exclusive, there is some overlap between these events. The probability that A or B will occur is the sum of probability of each event minus the probability of the overlap, which I demonstrated to you guys in the example of the girls getting the A grade. What is the multiplication rule of probability? The multiplication rule of probability explains the condition between 2 events. For 2 events A and B associated with the sample set, A intersect B denotes the events in which both events A and B have occurred. Hence, A intersect B denotes the simultaneous occurrence of events A and B. Event A and B can be written as AB. The probability of event AB is determined by using the properties of conditional probability. According to the multiplication rule, the probability of occurrence of both events A and B is equal to the product of the probability of B occurring and the conditional probability that event A occurring given that B occurs. If A and B are dependent events, the probability of both events occurring together is going to be expressed as the probability of B into the probability of A over B. And if if A and B are 2 independent events occurring in an experiment, then the probability of both events occurring simultaneously is given by simply the product of A into the probability of B. An example of this can basically be demonstrated by if an urn contains 20 red and 10 blue balls, 2 blue balls are randomly drawn from the bag one after the other without replacement. What is the probability that both balls that are going to be drawn are red? So in order to figure out the solution, let A and B denote that the events that the first and second balls are drawn as red. We have to basically find out the probabilities of A and B. So as you guys know, there were 20 balls, 20 that were red, so 20 over 30, which was the total number of balls. This is when they're going to be first drawn out. Now, once you draw out the first ball, there's only going to be 19 red balls that are going to be remaining and 10 blue balls that are left in the bag since we didn't pull out any blue balls. The probability of drawing a red ball in the second draw too is an example of conditional probability, whereas the probability of drawing a second ball depends on the drawing of the first ball. Hence, the conditional probability of B on A will be 19 over 29 because that's what the number of red balls were remaining after one was initially picked out. And in order to multiply this, we will apply the multiplication rule, which is simply 20 over 30 into 19 over 29, which is 38 over 87. So for independent events of A and B, the multiplication rule simply states the probability of A is multiplied by the probability of B. And for dependent events, it's going to be the probability of A into the probability of B over A. Another example to help simplify is that Christy basically has a bag of candies. In a bag, there are basically 5 colors. There are 5 red colors, 3 orange colors, and 8 green colors. She takes one candy and records its color and puts the other one back in the bag. Then she draws another one. What is the probability of taking out a green candy followed by a red one? So green is basically going to be 8 over the total number of the options that were 5 plus 3 plus 8, which is 16, into 5 over 16 because the second candy is basically red. And the answer for this is going to be 5 over 32. Now moving on to recent advances, this article is basically based on probability in medicine. And what it studies is that the term probability, apparently vague, is defined as the ratio of favorable in all cases. Sometimes it is expressed as odds, and the mathematical probability is calculated according to the following consideration: that during accidental tossing of an intact coin, the probability of head is half. Statistical probability is assessed experimentally, and if randomization is not respected, the result is doubtful, and we call that bias. Probabilities are multiplied if one or another phenomenon should occur. Phenomena which should not occur are frequently governed by binomial bias. According to the law of large numbers, the posterior probability will become closer to the priori probability the larger the number of experiments. Forecasts based on probability are based are made possible by interferential statistics. In this respect, they differ from the mere statistical description. Thus, optimal decision is achieved under conditions of uncertainty typical for medicine. This applies to diagnosis as well as treatment. In this way, a cutoff value can be selected for a given diagnostic test to achieve an optimal combination of the resulting sensitivity and specificity and the probability of disease and health. In case of a positive or a negative finding which can be expressed, the result of statistical testing, for example, in the effectiveness of treatment, is a rule presented by means of the probability value P as compared with the error alpha, which should be assessed in advance. It is, however, necessary to respect also an alternative hypothesis. However, this latter is unfortunately formulated only rarely. Another article is basically the current best practice for presenting probabilities in patient decisions aids the fundamental principles. The abstract for this is that the shared decision making requires evidence to be conveyed to the patient in a way they can easily comprehend and compare. Patient decisions aids facilitates this process. And this article basically refutes the current evidence for how to present numerical probabilities with patient decision aids. The results of this were that they basically recommended presenting numbers over a set period with a clear denominator using consistent formats between the outcomes and interventions to enable unbiased comparisons and interpreting the numbers for the reader to meet the needs of varying numeracy. The discussion for this was understanding how different numerical formats can bias risk perception will help decision aid developers communicate risks in a balanced, comprehensible manner and avoid accidental nudging towards a particular option. Decisions between probability format need to consider the available evidence and user skills. The review may be useful for other areas of science communication in which unbiased presentation of probabilities is important. Now moving on to the MCQs. The first MCQ basically states, what will be the probability of getting odd numbers if a dice is thrown?
Alpha.
Yes, it's alpha. Basically, for example, when a dice is shown, as we demonstrated, there were 6 options: 1, 2, 3, 4, 5, 6. So the total number is going to be 6. The probabilities of getting an odd number is 3, as the odd numbers are going to be 1, 3, and 5. So it's basically going to be 3 over 6. Simplified, it's going to be 1 over 2. Question number 2. The probability of getting 2 tails when 2 coins are tossed is?
B.
The answer is basically D in this case, because we're tossing 2 coins. So if you consider 2 coins, the options are going to be either heads, heads, or heads, tails, or tails, heads, and tails, basically. So there's 4 different events that can occur. And the probability that you're actually going to get a tails on 4 total outcomes is going to be 1 over 4. This is basically the explanation. And question number 3, what will be the probability of losing a game if the winning probability is 0.3?
B.
The answer for this is C. And it's simply going to be 1 minus 0.3, which is 0.7, because the probability of winning the probability of winning is 0.3. So as you guys know, there's always going to be a total number of the outcome is going to be 1 minus 0.3. Question number 4. What is the probability of drawing an ace from a pack of 52 cards? For this,
C.
The answer for this is B. And the reason for this is that there's going to be 4 aces in a deck of cards. So if we knew that if there are 4 aces, then 4 over 52 simplified is going to be 1 over 30. Question number 5. Events which can never occur together in probability theories are classified as mutually exclusive events, collectively exclusive events, mutually exhaustive events, or none of these.
A.
Yes, the answer is A. Question number 6. This is a relatively longer question to answer, but it demonstrates the addition rule of probability, so I included it. Basically, in this, what happens is that there's in a class, 30% of students study Urdu, 45% of students study math, and 15% study both Urdu and math. If a student is randomly selected, what is the probability that he or she will study Urdu or maths?
C.
The answer for this is 6B. And basically, for this, because it says that there's 45% of students who study Urdu. So first we simplified this fraction as 9/20. Then there were 30% who were studying maths. So we simplified that fraction of 30/100 by 6/20, and 15% who were studying both. So 15/100 was simplified as 3/20. Because as you know, the question states that what is the probability that he or she will study either Urdu or math? So by the addition rule of probability, you first add the probabilities of both Urdu and math, which was 9/20 plus 6/20, as I've shown you above. And then it was basically the students who were studying both Urdu and maths, which was 3/20. So the answer we go to is 3/5 or 12/20, because it's either the student studying either Urdu or math. Question number 7. In a lottery, there are 10 prizes and 25 blanks. What is the probability of getting a prize when a lottery is drawn at random?
A.
The question for this is, the answer for this is 7C.
B.
It's 7C. Basically, because there's going to be 35 total outcomes of this. There's 10 are the prizes and 25 are the blanks. So 10 blanks basically means the ones that are not the prizes. So 10 plus 25 is 35, and 10 were the number of prizes. So 10/35 is 2/7. Question number 8. In a box, there are 8 oranges, 7. There are 8 orange, 7 white, and 6 blue balls. If a ball is picked up randomly, what is the probability that it is neither orange nor blue? So in this question, we have to basically calculate the probability of white balls.
B.
This is just
C.
8. This is 8A actually, because as I said, the question is a little tricky in the sense that it states that what is the probability that it is neither orange nor blue. So first we add up 8 plus 7 plus 6, which is 21. And then we basically there were 7 white. So we had to basically calculate the ones that were neither orange nor blue. So that's basically 7/21 simplified, it's 1/3. Question number 9. The probability of a sure event is either 1, 2. Question number C is option number C is 3, and then option number D is 5.
A.
Yes, this is 9A. And lastly, in a special rule of addition of probability, the events are always A, independent events, B, mutually exclusive events, C, Bayesian, and D, empirical events.
B.
No, the answer, yes, the answer is basically 10B. You're right. This is the key.
Okay, thank you very much, Dr. Reda. Very nice presentation. There are many calculations that are involved, and as you have said, some of the calculations are very tricky ones. So I would suggest everyone must go this presentation once again when it is uploaded on the YouTube channel, and do the calculations with a little more time as the calculations, they are giving us the real insight into the probability and how the probability works when something is exclusively done or it is not mutually exclusive, but there are certain options that are inclusive in the probability. So very nice presentation, very well done. Thank you. Allah Hafiz.
Thank you, ma'am. Allah Hafiz.